when the question asks you to differ, okay, about between continuous spectra and also line spectra, okay, so you should be able to, okay, state the differences between these two spectrum. So what is a spectrum? Spectrum is actually a series of lines or a set of colors, right? So as I mentioned earlier, there are two types of spectrum: line spectrum and also continuous spectrum. So a line spectrum is a spectrum that contains a series of discrete lines. Okay, each line corresponds to a specific wavelength. Meanwhile, for continuous spectrum, it is a spectrum that contains continuous band of light radiation of all wavelength, so not discrete wavelength. So each line, okay, as you can see, is separated by a blank area. Meanwhile, for continuous spectrum, it is continuous, no blank area in between. Okay, so the sources for line spectrum is from the emission spectrum of atoms, for example, from gas discharge tube of hydrogen. Okay. Meanwhile, for the continuous spectrum is what we usually get in our daily life, which is from the white light and also from the sunlight. So this is the formation of line spectrum of hydrogen atoms. So hydrogen gas is filled in a gas discharge tube, right? Then electric spark is passed through the hydrogen gas. So this is the reaction that occurs, right? 1 mole of hydrogen molecule, okay, dissociate into 2 mole of hydrogen atoms, right? So the energy supply is absorbed by the electron of hydrogen atoms, causing them to be promoted from ground state to the higher energy level. Next, these electrons are unstable at their excited state. Then they fall to lower energy level and emit light at particular wavelength. So as we can see here, right? Okay, it absorbs the electron of the hydrogen atom, absorb energy supply, and then when an electron at the ground state, okay, absorb enough energy, it will move up to the higher energy level. But at a higher energy level or at the excited state, it is unstable. So when it is unstable, it will fall back to the lower energy level or to the ground state, okay, causing releasing light, okay, releasing light at certain energy level, emit light at particular wavelength. So we can split the wavelength, okay, by using this prism. So these are the answer that you should give when the question asks you to describe the formation of line spectrum. So you must start from its ground state lah. Okay, so when electron of a hydrogen atom at its ground state absorb sufficient amount of energy, it will move to a higher energy level. So at higher energy level, electron is unstable. It will fall back to lower energy level. During the transition, energy will be released in the form of light at certain wavelength and frequency. Since energy is quantized, the line spectrum is produced, right? So here are the process that you need to describe when the question asks you to describe the formation of line spectrum of hydrogen atom, right? But you must know that there is several emission. Means there are series of line spectrum obtained during the transition of electrons in hydrogen spectrum. What are there? There are 5, right? Starting from Lyman, Balmer, Paschen, Brackett, and Pfund. Okay, so you as we can see, Lyman has the lowest wavelength. And Lyman has the lowest wavelength, around from 0 to 150 nanometer, right? So from here, from right to left, okay, we have frequency increasing. That's mean energy decreases because energy is inversely proportional to wavelength. Okay, so energy decreases, frequency also decreases. Okay, so wavelength increases from left to right. That's mean the Lyman series has the highest energy, because from right to left we can see that energy decreases, or easier to see from left to right, it is vice versa. We can see that wavelength decreases, that's mean energy increases, frequency increases. So this Lyman series lies in the UV region. So as we know, we've learned about electromagnetic spectrum. Okay, so each of these line, okay, fall below specific electromagnetic region depending on the wavelength of the light emitted. So for Lyman, it lies in the UV electromagnetic region. Meanwhile, Balmer lies in the visible region, and these three, okay, lies in the infrared region. Okay, so here are the energy levels. Okay, this is the line spectrum. Okay, you must be able to differentiate between line spectrum and also energy level. This is the line spectrum. This is the energy level. So this is the possible energy level in the hydrogen atom. Okay, and transition of electron that produce the lines in the hydrogen spectrum. So as we can see, okay, Lyman series, its ground state is n equal to 1. So the first line belongs to the transition of electron from n equal to 2 to n equal to 1. Next, second line, okay, belongs to the transition of electron from n equal to 3 to its ground state, n equal to 1. Third line from n equal to 4 to n equal to 1. And okay, this is the continuum limit where the electron fall from the continuum line. Okay, as we can see, as I mentioned earlier, okay, when you are drawing the energy level diagram, please make sure that the difference between energy level will decrease as the principal quantum number increase, and as n increases, the distance between the energy level, okay, or the difference between the energy level, the difference in energy between the energy level decreases. So you can see here. So if so, you know that the second line, okay, the second line, for example, the second line for the Lyman series involves the transition of electron from n equal to 3 to n equal to 1. Right? So when the question asks you to describe, okay, so you should be able to describe the formation of second line of Lyman series. Next, we move on to Balmer series, right? If the question asks you to describe the formation of the third line of the Balmer series. So as we can see, the third line of the Balmer series, its ground state is n equal to 2. So the third line means that the electron fall from n equal to 5, energy level n equal to 5 to n equal to 2, forming this third line. Okay, it's very simple. So as we can see, for each transition from left to right, as you can see, the wavelength decreases. Okay, we can see the wavelength decreases. Okay, wavelength decreases. That's mean frequency increases and change delta E increases. So as we can see, the further the electron fall, that's mean the higher the electron from the higher energy level. So the higher the energy it will release. Okay, as for Paschen series, its ground state is n equal to 3, bracket series n equal to 4, Pfund series n equal to 5, its ground state. So the difference between these emission series is just its ground state. Okay. So this is if you would like to combine, okay, energy level diagram, use energy level diagram to describe the formation of line spectrum. For example, this is the Lyman series because we can see that its ground state or the electron fall back to n equal to 1. So that's mean the ground state of this series is n equal to 1. So it belongs to Lyman series. So the first line, okay, the first line belongs to when electron fall from n equal to 2 to n equal to 1. So this is the first line form. Okay, and then this is the second line from n equal to 3 to n equal to 1. The third line is from n equal to 4 to n equal to 1. And the fourth line is from n equal to 5 to n equal to 1. So you can see here, right? From left to right, okay, from left to right, energy decreases and wavelength increases. We can see wavelength increases. So that shows this is the fourth line. This is the third line. This is the second line and this is the first line. So it does not necessarily, the first line must start from the left. No, you must be able to um, determine the line of the emission spectrum based on the distance between the line. You can see, okay, from between the first and second white gap, second and third, okay, smaller, getting smaller, third and fourth getting smaller. So that's mean the wavelength decreases. Okay, from right to left, wavelength decreases, or from left to right, wavelength increases. We can see wavelength increases. So when wavelength increases, that's mean energy decreases. So when energy decreases, this correspond to the highest transition, or I mean the transition from the highest energy level available here, right? So as I say, the line spectrum does not necessarily means the first line must start from left. No, you must be able to determine based on the distance or the gap between the lines, right? The smaller the gaps, that means the wavelength decreases. When the wavelength decreases, that means energy increases. Okay, so let's take a look at the Balmer series when electron fall to n equal to 2. Okay, so as we can see, the pink line is represent the first transition, okay, the first line of the Balmer series, where the electron transit from n equal to 3 to n equal to 2. Okay, so we can see here, okay, from left to right, we can see that the wavelength increases. So energy decreases. So that's mean this is the third line. Okay, the third line. This is the second. This is the first line. Okay, so the third line is from fifth energy level to the second energy level. Okay, so we need to be able to determine. Okay, so this is a various series and atomic hydrogen emission. You can remember as Lyman, balik, pasar, bawa, payung. Okay, Lyman, because there are two B and P. So Balmer you can remember as balik, pasen, pasar, and then bracket Bifan. So the difference between this energy level is its final energy level. This means NF means where does the electron fall back to, or we can say its ground state. So for the ground state of Lyman series, n equal to 1. That means the electron will fall back to n equal to 1 energy level. So that means during the emission, the initial position of that electron must be higher than 1. Right? So initial energy level means its excited state. Must be higher than 1 because it need to fall from a higher energy level to lower energy level. So as for Balmer, the ground state is n equal to 2, so that's means the excited state is from higher energy level 3, 4, 5 and so on. Okay, the same for Paschen and bracket and Bifan. So you need to memorize this. And also need to memorize the spectrum region. Okay, so you can remember Lyman produces the highest energy transition. Okay, so it lies in the UV region. So U lihat I. You can memorize as that U lihat I. So Lyman belongs to the UV region. Balmer belongs to the visible region. So it can produce colors. Okay. Meanwhile, these three spectrum lies in the IR or infrared region. You lihat I. Okay, simple. So Balmer series is the only visible to the unaided eye. It contains 4 colored lines against a black background. So the first line is the red color, second line is the blue-green, third line is the indigo, and the fourth line is the violet. So you can see the wavelength decreases, so that means energy increases. From second line to the fourth line, okay, energy increases as the wavelength decreases. So this one you don't need to memorize, you just need to be able to know when the question give you colors, that means it belongs to the Balmer series.